Hi, we're looking at oil deposits, which today express evidence for the worldwide flood, creationism, short period of time, very short, or long periods of time, evolution. Worldwide flood seems to be the answer. We looked at BibleStudyManuals.net. We went to K31. Here's the top page. Just add in K31.htm. That's the file we're looking at. And we'll want to look up R.D. Sloan. Relative to oil, which is getting harder to find, he's saying the future of the exploration geologist. Consideration of the biblical point of view of geology could hardly do worse in finding oil than the track record of the evolution-minded geologists, which we discovered last time. As yet, in fact, uniformitarian geology has not been able to develop even a generally accepted theory as to the origin of oil or its basic source material, which would be essential in finding out where it is. While agreement is nearly complete on the organic source of petroleum, there are wide differences of opinion on the process by which it was formed and on the nature of the organic matter from which it was derived. Further differences of thought arise when an attempt is made to explain the transformation of organic source material into petroleum. Heat and pressure, bacterial action, radioactive bombardment, and catalytic reactions, each has its proponents as the chief source of energy responsible for the conversion. How about just a lot of water? It is apparent that once again, in this most important economically and in numbers of geologists concerned of all geological disciplines, the principle of uniformity has proved impotent. Although some of use is made of micropaleontology in correlation of oil-bearing strata, its economic applicability is almost entirely local. That is, geologists can identify a given formation from two or more well logs by the microfossils contained in the cuttings, but it's local, and thus orient the log with respect to some plane of interest of where oil might be, but this can only be done on a local scale within the confines of the given formation. The process has virtually no value or significance for regional correlations, and this is because the worldwide flood created rock strata that varied all around the world. So you find a minutiae little thing that fossil that you can find in a local area. Okay, that's probably the same place. You can find the oil, but you go across the county, you're not going to find the same thing. Fossil record varies all over the place. Professional geologists working in the petroleum industry are apt to lose sight of the importance of fossils, for within the confines of one oil field or even one sedimentary basin, bed tracing by lithologic characters and by electric logging makes fossils appear superfluous. They don't even bother with it anymore. As a matter of fact, the biblical doctrine of a universal catastrophic flood best describes the occurrence of oil. Walter Bucher. One important fact accounts in large measure for the difficulty in explaining the origin and geological history of oil, namely that oil has been found in rocks of practically all so-called geologic ages, except the so-called Pleistocene era. It is a feature essentially common to all stratified rocks and therefore cannot be easily located by means of the usual stratigraphic and paleontologic criteria for identifying rocks. They threw that out. Upon the model of evolution is based. Okay? You want evolution, you got to look at the rocks. But if it varies so much, there's no consistency. So evolution is not consistent. This fact also gives strong testimony that such a universal phenomenon as oil, found as it is in all the rock systems, must have a universal explanation. The conditions of its formation must have been essentially the same everywhere. Hello? Rather than to support thereby the concept of uniformity in time, this fact seems rather to evidence the fact of uniformity of manner of origin and formation, and thereby to imply one global event, worldwide flood, which somehow brought about the genesis of all the great oil reservoirs of the Earth's crust. All that water makes all that oil. This universal occurrence of petroleum is indicated by Cox as follows. Petroleum occurs in rocks of all ages, from the Cambrian to the Pliocene inclusion, but no evidence has been found to prove that any petroleum has been formed since the Pliocene, although sedimentation patterns and thicknesses in Pleistocene and recent sediments are similar to those in the Pliocene where petroleum is formed. Ben B. Cox, we would suggest that there must be a connection between the fact that the Pleistocene and recent sediments are post-Diluvian and the fact that in these only has no petroleum deposit been found. Otherwise, the reason for this fact is quite mysterious. A very few oil deposits have been noted in Precambrian and Pleistocene deposits, but these are known to have migrated into them after earlier formation and deposition in other sedimentary rocks. The absence of oil in Pleistocene rocks is all the more mysterious, in fact, due to the fact that some petroleum hydrocarbons have been found in recent sediments, indicating that long ages are not required for the formation of hydrocarbons. Worldwide flood. At the same time, these hydrocarbons are definitely not petroleum, which evidently requires special conditions of some kind that before it will form, like a lot of pressure, like a lot of water. W. Hansen says, although hydrocarbons form an important part of the organic fraction of recent sediments, crude oil, as we know it, has formed in these sediments even well beyond the zone of major bacterial activity. About all that is definitely known is that petroleum occurrences seem to have no particular relation to particular stratigraphic sequences or to structural forms. Neither the paleontologic history nor the deformational history appears to bear any necessary relation to actual oil deposits. Reservoir rocks that contain petroleum differ from one another in various ways. They range in geologic age from Precambrian to Pliocene, in composition from siliceous to carbon, silicon to carbonate, in origin from sedimentary to igneous, in porosity from 1 to 40%, and in permeability from 1 millidarcy to many darcies. Now, there's no pattern there then. There is a wide variation also in the character of the trap that retains the pool. The trap may have been formed as the result of causes that are entirely structural or entirely stratigraphic, or from any combination of these causes. The geologic history of the trap may vary widely, from a single geologic episode to a combination of many phenomena extending over a long period of geologic time. They are barking up the wrong tree. Pools trapped in limestone and dolomite reservoir rock, for example, have the same relations that pools trapped in sandstone rocks have to such things as the reservoir fluids, oil, water, and oil gas contacts and trap boundaries. Yet the chemical relations of this reservoir rock and the effects of solution, cementation, compaction, and recrystallization are quite different in sandstone and carbonate reservoirs. So something else did it. Worldwide flood. The most immediately apparent conclusion from all of this is that the accumulation of petroleum into traps must have occurred after all, or practically all, the strata were laid down, since they are apparently entirely independent of the particular type of rock, but are nevertheless similar to each other in hydraulic characteristics. The main feature that all such deposits have in common is that of being associated with water. Nearly every petroleum pool exists within an environment of water, free, interstitial, edge, and bottom water. This means that the problem of migration is intimately related to hydrology, hydraulics, and groundwater movement. Why didn't they come out of the... It's the worldwide flood. Another extremely important fact is that apparently all petroleum is organic in origin. There have been inorganic theories of origin in the past, but the accumulated evidence now is overwhelming that petroleum has an organic basis. The exact nature of the organic material has yet been quite unsettled, but there seems little doubt that the vast reservoirs of organic remains, both plant and animal, in the sedimentary rocks constitute a more than adequate source. The deluge once again appears to offer a satisfactory explanation of the origin of oil, as well as the other stratigraphic phenomena. The great sedimentary basins being filled rapidly and more or less continuously during the flood would provide a prolific source of organic material, together with whatever heat and pressure might have been needed to initiate the chemical reactions necessary to begin the transformation into petroleum hydrocarbons. Worldwide flood. Recent studies indicate that certain dilute soap solutions seem to be associated with petroleum formation, in that these can act as solubilizers for the hydrocarbons in the deposited sediments, which, when further diluted with water, permit the dissolved hydrocarbons to appear as discrete oil droplets. Thus, it would seem that crude oil originates during the compaction of a sedimentary basin by virtue of the fact that the sediment hydrocarbons dissolve in waters containing natural solubilizers and then come off solution as oil droplets. The composition of crude oil, as now understood, is consistent with this hypothesis. E.G. Baker. Different specific types of solution mechanisms appear to account for the different types of crude oils. Constituents for the solubilizers would certainly be available at many places during the deluge, especially in areas of heavy organic deposition of marine animal remains. This process of oil formation implies, too, that oil was formed over wide areas rather than in the relatively limited locations in which it is found. Such a mechanism would lead credence to the suggestion that the source leads of petroleum are not necessarily unique accumulations of hydrocarbons in a limited area, but rather may generally be coincident with the area from which water is expressed into the porous strata that eventually form the reservoirs. The general picture of vast organic remains, somehow dissolved and transformed chemically into petroleum hydrocarbons, then eventually reciprocated as oil, and is basically valid and harmonizes well with the concept of catastrophic burial and dissolution during the worldwide flood, the deluge. The process of gradual accumulation into oil pools and reservoirs is then, from here on, basically a hydraulic problem. The oil droplets, by buoyancy, tend to rise up through the surrounding water and thus gradually to accumulate at the upper surface of the water. Oil floats on water. The extent of this transportation, the amount accumulated, will depend on the hydraulic gradients and permeabilities of the containing strata. This, of course, has nothing to do with the fossil contents of the strata, but very little to do with the tectonic history of the region, except to the extent that particular formations which are either permeable or impermeable, as the case may have been distorted in some way. These hydraulic processes have been continuing since the deluge, gradually concentrating the oil that was formed at the time, and soon after that into traps. But there is no reason at all to think that these processes may have required long ages of time to be accomplished. As already seen, even some modern conditions, petroleum hydrocarbons can be formed rather quickly. More recently, a school of thought has developed which believes that oil formation may begin soon after deposition of the organic matter in the sediments. One of the surprising results of this study has been the discovery of liquid hydrocarbons in recent sediments from the Gulf of Mexico. P.V. Smith. Similarly, the traps that form the pools needed to have taken long to form need not have taken long to form. Although no primary oil deposits are found in the Pleistocene strata, it has been shown that certain of the traps found in the earliest strata were actually formed during the Pleistocene time, which, as we have seen, is in our framework, the post-deluge. And as an example is the Ketlama Hills pools in California. The oil and gas of this pool are in the Miocene Temblor Formation, but the fold is parallel to the Pleistocene rocks at the surface of the ground. This places the accumulation in late Pleistocene or post-Pleistocene time, an illustration of the short time for a pool to adjust itself to a change in conditions may be seen in the tilting of the Cairo pool in Arkansas. The tilt occurred within a period of 10 to 12 years. If it had gone on for a few more years, at the same rate, the oil would probably have moved completely out of the trap. Thus, the time it takes for oil to accumulate into pools may be geologically short, the minimum being measured possibly in thousands or even hundreds of years. So the character of petroleum deposits, as such information has been accumulated regarding the origin and the migration of oil, harmonize quite well with the deluge hypotheses. Dr. Don Patton says, a beautiful example of this phenomenon is seen near Cooksville, Tennessee, in the coal measures there. This tree, standing upright in the sediment, actually extends through 2 cyclotherms. Cyclotherm is a series of 10 different rock units where we find coal formed. And this series of 10 rocks repeats some 50 to 100 times. Trying to explain these cyclic deposits by normal uniformitarian process gets very entertaining because it's ridiculous. I think the tidal forces of a huge flood are much better at explaining the cyclic forces. But if we look at the picture and notice that we've got coal down there near the bottom that extends through the numbers of layers up